Yep.
Ready to start? So, hello everyone, welcome. We are Team VSync. I'm Dan.
I'm Tyler.
Kadir.
Yankee or Jay.
And this is our interim presentation. So what we're going to be doing today is we're going to be giving a quick introduction as to our project. We're going to be going over our project requirements and goals. We're going to be going over the development process, technologies and design, how we went about testing, giving a quick demo, and then finally some of our risks and roadblocks, as well as where we're going forward. And then at the very end we'll do some questions, so we ask that you hold your questions till the end.
So for our project, we are implementing a voice-based user interface on top of a web-based user interface that implements a specific subset of the functionality. And for that, we chose to use the Amazon Alexa because it's the biggest, it has the biggest market share right now for that product for voice-based home assistants. And we also wanted to go with that because our sponsors and their users want to stay up to date and relevant in a world that has become more and more voice-based. And if you were to split that functionality into two parts, one of which would be improving content access. So that content access is mostly news-based, but we want that access or that content to be available to users in a very natural and spontaneous way when they're speaking with the Alexa skill. And then on top of that, the project aims to implement to reduce the reliance of our sponsors that they have on their call centers. And we're doing that by focusing on what the call centers do most for their users and then trying to solve those problems for them.
So onto the requirements that we gathered from the project synopsis that we were given, as well as speaking to Synacor to try to understand the scope of the project that we were going to be working on. We gathered two main functionality requirements, which are account management, including logging in, configuring your account, things of that nature, and a news reader where you'll actually be having the Alexa read news to you from specific categories and starting to learn your preferences, things like that, as well as some non-functional requirements that include usage tracking, so we have an idea of what intents are being used often and which ones we could improve on. This also includes security and auditing, so we want to make sure that things like the password resets are being tracked so we know when people are using it, hopefully why. And then we also had in mind designing to accommodate multiple types of home assistants, so Google Voice and the Apple's version as well. So we spent about the first two sprints, as we'll get into our methodology later, trying to iron out these requirements. And as we went forward, we actually had to negotiate with our sponsors to decide which ones we wanted to tackle first and which ones were a little bit lower priority or more difficult to implement. So we decided that the things in white were very high value, things we could implement quickly and get out to the users as soon as possible. And the things in red, like recognizing the user by their voice, very difficult to do with the Alexa. Bill pay, there are legal concerns about having the Alexa pay for things for you. Push notifications to your phone, it's very difficult to actually integrate that with the Alexa as well. And then designing to accommodate multiple interfaces. So the Google Home and the Apple's version are actually very different in how you would interact with them as opposed to the Alexa. The code isn't exactly easy to carry over. So all of those in red are lower priority things that we thought we'd come back to when we get the chance.
So our development process is an agile development process. We went with Scrum for our development process, and the main reason for that is because one, our sponsors wanted us to, and two, we felt that it was a good solution when we have requirements that keep changing, and every week we're negotiating new requirements, whether we can do them or not. So Scrum was the right choice for our purposes. Our general schedule is we have a sprint length of 2 weeks, and throughout that sprint we meet with our sponsors 4 times. So it's great because we can meet with them frequently and we can give them status updates, and we can basically talk to them about requirements and if what we're working on is correct or not. First Monday of the sprint is always sprint planning, so we plan out our work for the week, make sure that our sponsors are aware of what we're going to accomplish throughout the sprint. Then the second Monday of the sprint is usually backlog grooming and just sort of determining if we're on the right track or not, if we need to move some requirements around. Then the first Friday of the sprint is kind of just a status update. It's great because we can meet with our sponsors after the first week of working on something and then determine if we need to work on it some more or if we need to maybe add some additional time to that item. And then the last sprint, the last Friday of the sprint is a demo where we demo what we've accomplished during the 2 weeks. Some of the artifacts and metrics that we are tracking for this, this is a burn down chart of, I think this is our previous sprint actually. This one's a good one to look at because it's pretty linear, but we've gotten much better throughout the sprint, throughout the project cycle in breaking down stories and determining exactly how many story points need to go into a story. The first sprint we did was more like a cliff. We just had a bunch of, it was just a line that went way over and then just dropped off because we didn't plan correctly. So we've gotten much better at planning throughout the duration of the project. The second key artifact that we're using for our development process is our project board. This is where we plan basically everything we do from here. We point things, as you can see, this is a 3-point story that we have currently. I think this is a pretty recent picture, so we have nothing in our sprint backlog right now because we're not working on anything this sprint. It was just kind of finals and making sure that we got those out the way before we started work again. And then in our product backlog, we do have a bunch of stuff to start work on once we resume our project.
So this is our overall diagram and design. Before I mention and go through this diagram, we want to mention our scope. Our code only lives in AWS Lambda, which is serverless computing services provided by Amazon Web Service. So what it does is we just unload our code and it runs our code without the server running 24/7. So let's go through our diagram. So once our user speaks to Alexa Echo, and Echo transfers our voice data into Alexa voice service. Once the voice service takes the data, then it interprets the voice and determine what skill to use. On the way, it may actually also talk with the OAuth server because some skills may require authentication and etc., all the security stuff. Once that is resolved, then the Alexa voice server generates the JSON request JSON and sends it over to Lambda. Once the Lambda takes the request JSON, then we interpret those request JSON to handle those intents and stuff. On the way we're handling those intents, we may talk with Alexa Skill Kit and Cinecore APIs to accomplish what we want to have all the functionalities. And this is a little bit diverse and compact. It's a sequence diagram for our specific intent. Oh, by the way, intent is by definition represents an action that fulfills user spoken request. So what it does is basically a function for user call. And it has exact same flows with the previous diagram here. This overall design, that kind of copies and pastes up until this point. So what it does is it sends over the request to the Lambda and our OAuth server and asks for the confirmation. Once the user once the request is delivered, then it Echo asks back to user for confirmation. Once the user confirms, then it goes all the way down back to Lambda, handles all our code, logging, API requests, services, etc., comes back, and finally, Echo speaks to the user. So in order to build that, we are using following technology stacks. First, we're using Alexa Skill Kit SDK version 1. We're using version 1. It's pretty recent. It's been out for about like a year and a half. Even though there's version 2 out, we're still sticking with version 1 currently. And also building Alexa skill using SDK is necessary to building those applications. And also following AWS are used along with Lambda, CloudWatch, and command line interface too. Lambda, I mentioned before, is just a serverless computing service, so it runs our code. CloudWatch keeps track of our logs, so we can track of bugs, errors, etc. And a command line interface is used to deploy our code automatically. Next, we're using Cinecore API because we're implementing Cinecore website into voice interface echo skill. And along with that, we're also using OAuth 2.0 because Alexa requires for that. And lastly, we're using also the Node.js. However, we started as using Java originally because our sponsor, Cinecore, wanted to use Java because they have all the code base in Java. However, we figured through creating Hello World testing application, and turns out the performance of running the skill app in Java takes much worse performance issue. So we decided to change over to Node.js. Lastly, we're using Jenkins for continuous development environment.
So testing. Testing is something that no one wants to do, but is pretty much mandatory for any product these days. Testing for our purposes was actually extremely difficult. We ran into a lot of problems, primarily because of account linking issues. And basically what we have to do is, in order to get data from Cinecore APIs, we have to have the user log in to the skill. And the skill provides an OAuth login, so we're using the OAuth 2.0 protocol. And trying to automate that login process is basically, it's very difficult to do. So what we did to get around that is we basically have an OAuth token that we injected directly into our OAuth server that almost never expires. So we can just use that token and we can inject it into the request JSON directly, and then pass that request JSON to our code and simulate what it would be like if we were actually talking to the device itself. So if we take a quick look at this code here, this is some example JSON of basically what we send to our code to get our code to do stuff. This is what actually the Amazon cloud will send to our code to get it to do stuff. So this is basically a mock of exactly what the Alexa cloud would do. The only important part of this really is at the bottom, the request data. This request data basically has the name of the function that we want to call in code. In this example, it's launch request. So a launch request will basically test our launch request function and make sure that it's outputting the correct values. Now we're going to give a quick demo of what we've been doing so far.
So we'll just start with the actual account linking portion of this. So to do that, give me a second to find my mouse.
Usually the account linking would be done inside the app, the Alexa app itself. But for the purposes of this demo, we can also do it online. So we're just going to show what it looks like on the computer.
So you're going to come to the Alexa's web application, and you're going to enable the skill first.
You are 1.45 miles, 2.33 kilometers, northeast of the center of Washington, D.C.
Stop. Sorry about that.
So now that we're logged in, we can enable the skill. It'll ask you the permissions that you want to give it, and then it'll take you to an OAuth authentication page. This is already logged in for me, so it takes us straight here. And then we'll just hit allow to allow the skill to access what it needs to. So into some of the features that it actually can do, Alexa, get my username.
Sorry, I don't know that.
Sorry. Alexa, ask cable code to get my username. Alexa, ask cable code to get my username.
The username for the current account is KXA8968.
The use for this, for Cinecore's side at least, is that they actually receive a lot of calls to their call centers asking about the username and the email associated with the account. So if this is stored in the Alexa, the user can just ask directly. Sorry.
It's very sensitive to when you say Alexa.
Okay. Moving on to some of the other functionality. Alexa, ask Cable Co to get me news.
I have retrieved 29 articles. I will read the title of each article. After each title, you may ask me to read the title again, read the summary, or continue to the next article. Say next or read the title when you would like me to begin.
Next.
The title of the next article is Man Accused of Posting Prince George Info Denies Terrorism. What would you like to do?
Stop.
Thank you.
Is there anything else I can help you with today?
No. So as you can
Thank you
see,
for using
it pulls
Cable
some
Company.
articles from Cinecore's APIs, and then it reads them out to the user. And that way the user can go through those articles, get the descriptions if they need to, and then the last part of the features that will actually show on the developer console, resetting the password.
Yeah, so the reason I wanted to show this in the developer console, which is basically an online test tool that they provide us.
The last one.
If I can find the mouse.
Refresh the page.
So this is a tool that Amazon actually gives us to test our system, and it allows us to basically type in anything we want, and it will do it. So for the purpose of this, it probably still work. Yeah, so you can't really hear it because the laptop's kind of quiet, but pretty much I just wanted to show what the request JSON was looking like. So when we were discussing the testing, this is the request JSON that Alexa actually generates and sends to our handlers. So this is what we were mocking right here. It's a lot more complex when Amazon generates it because it generates a bunch of session tokens and stuff that aren't mandatory. But basically, this is what the request JSON looks like. The reset password asks for confirmation, so we're just going to say yes.
A password reset link has been sent to user KXA8968 with email address kxa8968@rit.edu. Please check your email for further instructions.
So yeah, that's what the reset password looks like, and then you would get an email in your inbox with a link to reset it.
So some of the major roadblocks in this that we encountered so far in the project include just a general steep learning curve. I'm sure that most of the teams here have encountered some degree of that, but for us, none of us have ever developed an Alexa skill before, and I don't believe our sponsors have either. So there aren't a lot of resources for us to use and leverage in order to get going. You could also throw the fact that the SDK is less than 2 years old, like version 1 of it, so there aren't a lot of Amazon resources either to use. So that led to a lot of refactoring of the code that we didn't really anticipate. So in order to ensure the code was of better quality, we wanted to make sure to spend the time to refactor it continuously. As we've already alluded to also, the account linking has been a problem for us. That was mostly because we didn't actually have an OAuth server to begin with in order to authenticate with our sponsors' APIs. So thankfully there was very little downtime with that because they came through and provided that for us. In addition to that, we have some AWS and Jenkins setup problems. That's mostly concerning the permissions, but we feel like it's more typical of a development effort like ours because we're kind of part-time in this and we don't really have any experience setting it up, so we can't do it properly while also continuously delivering working software. And then design changes, that kind of loops back to the steep learning curve and the immaturity of the SDK. We made a lot of refactoring and efforts to resolve our tech debt already. And we hope that moving forward into the summer term that'll lead to a lot more efficient development.
So in terms of what we're planning on doing looking ahead to our next semester working on this project, We will be investigating the version 2 of the Alexa Skills Kit SDK because it actually came out very recently. I think it was during our last spring. We realized that it was released, and upgrading to this actually takes a lot of effort. It's not completely compatible with the version 1 of the Skills Kit, so we're looking into whether or not it's valuable and worth upgrading to. Remembering user preferences for news articles, we're looking into multiple different ways to do this. One of them is machine learning to try to understand what users prefer to hear about when they're asking for news, to try to make it more geared towards specific users instead of general news. We'll also be revisiting a lot of low priority requirements and trying to gather more requirements that Cinecore would like to see in the Alexa skill, because we've been moving along a little bit faster than we actually expected. Demoing this to Cinecore customers is a possibility. And then completing handoff procedures at the end of the next semester. We'll just be finishing up everything, documenting it, and then handing it off. So, questions?
No? We were that good? Yes.
How do you manage sessions across Alexa? Across Lambda?
So the request JSON actually contains a lot of that information for you while he scrolls back to it. Essentially, there's a session stored at the top, and if the session is new, that means that it's going to be, it might be used again or it might not. Essentially what happens is if you have an intent that requires you to speak to the Alexa again, it will let you know that there's a specific variable for it, and then it'll know that it'll expect another response afterwards.
Yeah,
and it
that-
saves a lot of the state in this JSON itself.
That session data, you can literally just put anything you want in there, and it will carry over to the next request if it's not a new session. So you can pretty much store anything you want in, so long as it's in a JSON format.
So, just a question, for example, in my parents' house, we have an Alexa in the dining room, and then we have one down in the basement. Do you have any way of transferring a session, like, from one Alexa to another? Or is that a planned possible thing, or?
In general, the Alexa intents are supposed to be very short-lived things. It's just supposed to be you ask Alexa for something, and then it returns you a response. In the case of news, we actually have to store the articles at least a little bit so that we can actually read them back to them when they say next or something to that effect. But I'm not aware of a way to actually transfer it between Alexa devices. I'm not sure if that is possible. I can't give you a full answer on that.
Sounds like a new requirement we should evaluate. Yay, Scrum.
Is there any other questions?
All right, let's thank the team.
we're the recruiters. My name's Aiden.
I'm Ryan.
I'm Nick.
I'm Jan.
Our sponsor is Jim Bondi, sitting over there, working at the Office of Career Services and Cooperative Education, and our coach was Dan Krutz.
Bless
There's a brief outline. We'll go over background and domain, do a little bit of our work breakdown, what we completed, show a demo of that, what we have planned, and go through the technical background, process, and reflection. So starting with background and domain. So the problem context we had was connecting applicants and recruiters. So the existing job process is very frustrating for both students and recruiters. It involves, especially for students, and you guys I'm sure can all attest to this, many expensive and recurring searches taking place over a long period of time. The preparation of full applications up to even like cover letters and full PDFs, and a lot of wait time. You send it out and you kind of maybe you don't hear back. You never know how well you're doing. From the recruiter side, you create a job posting and then you just receive dozens and dozens of full resumes and cover letters to parse through. All in all, we found that in our survey we conducted that over 60% of students could only process up to 10 jobs in a given hour, which is a pretty low rate. So yeah, just a summary of the frustrations. It's very high cost, so you have to put in a lot of work at the very front to apply to any given job and to find them to begin with. You then have low visibility into the application status. A lot of the results that you do find aren't that relevant to what you want, or you don't qualify for them. And then the overall process is just very high intensity, low yield. You only get a few responses back. And we found this not only from ourselves, but from the survey we conducted with students, as we saw in the previous slide. So our proposed solution. So what we want to do is we want to focus and kind of break down the process of applying to a job into a series of discrete phases. Ideally, on that first phase, we want to automate as much as we can. So things like filtering based on location, or filtering out students that don't have the sufficient skills or work experience is kind of priority one. And then it should hit the students immediately with a basic idea of the highest value of information about the job that's coming to them in a discrete basis, focusing all your attention on just that one job at a time and then scaling up. So you have multiple kind of thresholds. First, where you just are matched automatically. Second, where you have like a very brief look at what they work on and provide the recruiter with a little bit of information on what you do and what you have experience with. Kind of going back and forth between the recruiter and the student, and then the last final phase of the presentation, showing some information about your work in the past and how you want to portray yourself. So generally, we also want to simplify the inputs, especially for recruiters. Instead of looking at an entire resume, we want recruiters to be able to just really quickly see a bit of information from the student and say whether this is good or not. And incentivize speed especially. We want to make this be able to happen as quickly as possible and ease the entire process. Incentivizing speed with expiration times and with competition among different offers. So we see on the right just a diagram of kind of the basic process. The recruiter creates a job, the student kind of views each job in sequence, and then decides whether it's worthy, whether they like it or not. Does a brief problem statement, sends it back to the recruiter. The recruiter then approves or denies, and that's all they do. Then the student kind of views the video that's attached to the job description, submits a video of their own or a presentation link, such as their website, sends it back to the recruiter. The recruiter then approves or denies very, very quickly, and they're both matched in the final match screen. So this process in general was implemented by a previous team. We took it on from it being a proof of concept and a prototype, and have been tasked with productionalizing it, adding an API integration, and kind of getting into the app stores and in the hands of users.
So we'll just start off talking a little bit about the project that we inherited, specifically here with the server to begin with. Briefly touching on the technologies, the server that we got was built with Java using Spring and Hibernate and communicating with MariaDB. And when we received this, one of the benefits of it was already this proper separation from the client. It acted as a resting API. And this was good for us because we were able to implement our client in whatever way we needed to, and as we'll see when we talk about the client, it was implemented with entirely different technologies, so this separation allows us to do that. The server, when we received it, already had authentication and authorization built in. It had user registration. It had basic endpoints set up to interact with this data, so just your typical create, read, update, destroy endpoints, just for the basics here. There wasn't any elaborate functionality for these endpoints as far as the matching system goes, but it was there for the sake of getting through that process. And then, of course, the matching system, which is the core of the entire application, generating these matches based on skills and like skills of the job and skills of the students and other areas, that was in place as well, just creating these matches based on a match score. So that's what we received, and some of the weaknesses of this, a lot of the unit tests weren't passing when we received this. Now, the server would still work fine whenever we would build it to try and put it on a production level server. Essentially, we weren't able to build it when we received it because its unit tests were failing. So we had to dedicate some attention there, of course, and then also no API testing framework was implemented at all. There was those unit tests, but as far as testing the endpoints externally using Postman or even documentation with Swagger or something of that sort wasn't implemented. So now on the client side of things, you can see the screens there on the right. That's the screenshots of the original application that we received. It was built using Xamarin, which is essentially, if you don't know, it's just a framework to build cross-platform web apps in C#. So what we received with this was that login and registration. It had this end-to-end process that we spoke of being able to see, because it was intended to be a prototype to see the viability of the concept. It had this end-to-end process and the different phases that Aidan spoke about in that pyramid, the problem phase, the presentation phase, the final match, etc. So it had this all sort of laid out to show you, but as we can see, it didn't look that great, and there were some other problems with it as well in terms of workflow. A lot of the requirements that were introduced to us with this project by our sponsor sort of changed the way that this client needed to work. So that is essentially what we're considering one of the weaknesses of it, because it was intended to just be a prototype, so a lot of it needed to be revamped essentially. Another weakness is that we're considering the fact that it was implemented in Xamarin a weakness for us, because we didn't have a lot of familiarity with Xamarin at the time, and we knew that Xamarin Forms, which is how the UIs were built, would make it difficult for us to implement better looking UIs in a short period of time. So that was a problem for us originally, and we had to sort of adjust our scope because of that. So looking at the work breakdown of sort of how we responded to this, we took this project, and the first thing we did was we decided, okay, how viable is it for us to do this in Xamarin? Or should we switch to something else? So we discussed it, and we decided to switch to the Ionic framework for many reasons. One, we were familiar with Ionic, or at least familiar with the technologies, JavaScript, HTML, etc. We all knew them well enough, and we knew that would improve our speed, and we knew that making this switch would allow us to take time out of scope that meant we had to divert energy towards learning Xamarin and improving the UI using Xamarin Forms. So in the long run, making this decision for us would allow us to bring more requirements in that our sponsor wanted and implement these features rather than have to divert time to learning an existing system. So, and also that Xamarin being the way it was, we were talking about implementing a third technology to have a web portal to access some of the same things instead of only having a client application on your phone, because some things may be better for recruiters to view in a web application on their computer and not on their phone. Using Xamarin, we would have to implement that client application for the phones and then a separate application for the web view as well. So we didn't want to have all these different technologies, so we landed on Ionic. Another thing that allowed us to do, like I said, is improve the UI, because Ionic just uses HTML and CSS to build the views. We were familiar with that, and we were able to produce this very quickly, and that led us also to providing Adobe XD mockups, which were a big part of our process going forward, because we were able to provide these mockups ahead of implementation and show them to our sponsor and get feedback on them to really see this process sort of building as we went. Another big thing we did during this iteration here was the discovery and elicitation. We did a lot of discovery work into the various APIs that we're thinking about implementing. We did a lot of discovery work into meeting with individuals on campus that already use certain technologies, such as Handshake, that we're thinking about integrating, to gain an idea of what we may need for that. And we also did the surveys that Aiden mentioned, so we got some feedback from students and recruiters to get an idea of how that might affect our requirements, to elicit what would be more important for us to include. And then lastly, one of the big things we did was implement a lot of testing beds and improve configuration. So we implemented Postman API testing to be able to test all the endpoints that exist on the server. We implemented testing on the client, which didn't previously exist. So we sort of have this much better foundation going forward. So touching on the UI evolution that we mentioned, the image on the left is the existing application, and the image on the right is the current application, and these are representing the same screens here. You can see the one on the left is just stacking all the matches at once, and it doesn't look that great, A, but B, it's also not very user-friendly in terms of UX. So we wanted to refine the focus a lot and make sure that you're only doing one match at a time. So you can see specifically what you're matching on for that match. You can read some of the details, and then you can decide if you're interested or not right there. So you don't have to sift through this big list, and this kind of helped our process speed it up. Like we said, that was important to speed it up. So we'll just go into a bit of a demo here. The application is working on phones, but we decided to record it on a phone for sake of brevity and not fumbling around with that. We just wanted to record it ahead of time to avoid any complications here. So looking at this video here, we just start at the login screen. We'll just log in with the student we already created. And we'll see right off the bat that we don't have any matches right. So we don't have them right away because the student has no skills yet, and it even says here, perhaps you don't have any skills, maybe you should update your job preferences and you'll get some matches in the system. We already have a few jobs in the system already. We didn't want to show that process again for time's sake. So maybe let's add some skills. So we go here, we add these skills, sifting through this list, we add a few. This list isn't exhaustive. This is just the list that we have currently right now for the purpose of this demo. So we go through, we realize maybe there's one we couldn't find, so we can even search for them, trying to get these little user experience improvements throughout here. We select our skills, and you'll see as soon as we save, we immediately see jobs that were generated. So as soon as we add those skills, it searched jobs in the system that had the similar skills and that had similar areas that should match, and it generated these matches and pulled them for us instantly. So we see right away that we have these skills, and you can take over to talk about the problem spaces.
So very quickly, we show the first initial information about the job itself. Notably missing from this initial job review screen is information about the company, which was important to our sponsor and to us to hide until the next step after one was approved. This made sure that all the information about the job was kind of unbiased towards the company name, and also that you could focus on just strictly what was important about the actual roles. You mentioned again the check marks there. So here we clicked that we were interested in the bottom right. And now we're seeing the company problem statement that we mentioned. This is we're kind of working on this with our sponsor a little bit more to refine this, but the idea is that the company provides some information about what types of problems they're solving at the job. And if that kind of interests you, you can go right and, yeah, that one was uninteresting, sorry. So this one, we see a front-end developed for a social network where you're looking at the problem statement. This one interests us. Get a brief description there. It's like less than clicking in the eye. And we can kind of respond to that problem statement of the company with a problem statement of our own. Here you can actually name and perpetuate these into the system, so you don't have to constantly write these from time to time. So here we're labeling it so it can be viewed later, and then writing a brief statement about what you've done in the past that would relate to the company and how this might be. And this is going to go to the recruiter for them to approve or deny your problem statement.
And for time's sake, of course, we just skipped ahead and didn't fill out a full problem statement. So moving on to the presentation phase.
Okay, so here we're in the presentation phase. So at this point, the company has approved your problem statement, or your problem in the problem phase, and you go on to the presentation phase. So here you're given the presentation phase of the company. You're just given a link to a video so that you can view the video and see what type of work this company does and either approve or deny it.
We're going to add more information on this screen later in a future development.
So if you click on the link to look at their video, open up a new tab so you can kind of see what kind of work they do at the company, see if it's a match for you and what you want to do. And then you can go down, you said, so this person said they were interested, and now you give a presentation link of your own. So this can be a video or any link really to maybe your GitHub account or your personal website, whatever you want to show to the company that you think would interest them. So you can give a title to this link. So this is going to be a personal website, and then you would put the link right here. So you give the link, and then that will go to the company to look at and review, and then they can either approve or deny you based on that. And here's looking at another presentation phase of another company. And then after that, since you've gone through all of them, there are no longer any jobs in the presentation phase. Okay, so now we're going to be talking about the planned work that we have for the summer. Some things that we want to focus on are filtering. So we want to be able to add filters to students' profiles, such as location or company size. And then once you put these filters in, the system will check that jobs match those, and it will only match you if they check those filters. We also want to add more robust matching because the system is very simple right now in how it does the matching. We also want to do API integration, so we're planning on adding Handshake integration so that recruiters can just import jobs that they already have in Handshake and then bring them over into our system so that they don't have to go through the whole process in our app. We also want to do a web portal so that admins would use this at a university to approve companies. So if you want to add a company to the system, you have to request it, and then the admin can approve it, and then they can start adding jobs into our system. And we also want to productionalize the app, so making sure that it's ready for deployment, focusing on issues like security, and just making sure that it's ready to be deployed and used at a university. Now we're going to look at the technical background of our application. So here's some of the architecture. This is a component view of the system. So on the left you have the server, and on the right you have the client. So the distinguishment between these two code bases was made in the previous project, and we've been making this more robust throughout the semester. So on the right you have the client. So on the right of the diagram you can see that you use the phone application to access everything. And there are different components in here that deal with students, recruiters, companies, the different aspects. And then these will send over requests to the server that we have. So the server will get these different HTTP requests, and we're using Spring and Hibernate, and basically that will route to the specific component based on the URL of the endpoint that you're using. So then there's different controllers such as for matches, students, recruiters, and companies, and then we have connections to the database in those endpoints. And then here's a sequence diagram of our matching system. So this is from the student's perspective. So when you create a student or you update skills for the student in the system, it will then go to the matching service, and then based on the skills of the student, it will look at all the jobs and see if any of your skills match the required skills or nice to have skills for each job. And then it will basically determine a value for the match between you, the student, and the job. And then if this match value is above a certain threshold, it will create the match object and then save that to the database so that we can access it later. Now we're going to be talking about some process and metrics.
So our process, we use evolutionary prototyping, and we met 4 times a week, usually on Mondays and Fridays. And our team, we would delegate work, we would go over code review and discuss and reviewing the different tasks, whether it's completed or not. On Wednesdays, we met with our sponsors to talk about different feedback and the benefits of evolutionary prototyping. And our iterations are typically between 1 to 3 weeks. And again, we talked with our sponsors about prioritizing and maybe some feedback to work with our iterations. for testing. We used Postman, and that was a big part of using, we used Postman for testing all the endpoints in the API to ensure that it returns the data we want to see. We use technology like Jasmine and Karma and JUnit to test our client and our server code. And we use Travis CI for automated testing every time that anyone would push. We would use Travis CI to automatically test the client and server code every time someone pushes new changes to the code. For the metrics, we had a hard time with time tracking. We focused more on other work with the metrics, like GitHub and Jira. We checked the contributions.
So from what the contributions to Recruiter, our assistant server, from the past team, you can see the two comparisons up here on the chart. And so we have the graphs down here that show more information and breakdown on that.
So these are all right. We're going to have to move along. Let's move to questions, please.
Apologies, questions?
So your database is probably going to scale very quickly. Why narrow DB over
Yeah, so Maria was a decision made by the previous team before us. We didn't find a significant enough reason, given any load, yet to make that change. And we imagine a summer co-op might be a good time for someone to reinvestigate that look at realistic real-time loads after we've completed the productionalization step.
Yeah, and a part of our, like we mentioned, productionalizing at the end, something we have planned for quite a bit towards the end of the project. That's something we'll look into as well, load balancing and making sure all that's solid for production.
Yeah.
You guys are taking those presentation data, like videos and GPT slides, etc., right?
Mm-hmm.
Are you guys redirecting it to the link on the web, or are you storing it?
Yeah. So in future, we are storing it in the database. In the future, it'll be displayed in a view or of some kind on the client.
Okay.
Any other questions?
Thank you, team.
All right, good afternoon, everyone. We're Team Pterodactyl. We're working on the tax-efficient retirement income system. My name is Hunter Kasky.
I'm Matthew Manser.
I'm Nelson.
So our sponsors are Belziani and Associates, which is a small financial planning services firm located in the Rochester area. And they couldn't be here today due to work obligations, and a new baby. Congratulations to him. But the primary services that they provide, or as a fiduciary firm, they provide a number of services, of which we're interested in the retirement planning service. So they identified their problem, which was that their commercial tools followed a certain set of assumptions as to how to withdraw money during retirement. And while these assumptions may be valid in a flat tax system, the U.S. uses a graduated income tax. As such, they commissioned the Terry system to help them test these assumptions.
So we wanted to give a quick overview of the domain space that we're working in. So taxation and financial planning is a pretty complicated domain, so just to get the terminology, we're going to try to guide you through this crash course as best as possible. So if we start with the concept of people, we know that people have a variety of different monetary accounts that they have to represent their money. These are broken down by types. Sorry, the resolutions are a bit off on the right border. So these types are categorized as Roth, individual retirement accounts, or IRAs, qualified accounts, which are further broken down as 401ks and traditional IRAs, and we also have non-qualified accounts, which would consist of accounts like mutual funds and stock options and things of that nature. So these different types of monetary accounts represented over here are subject to the United States federal tax code, and within our problem space we represent those in terms of specific business rules such as required minimum distributions, income taxation calculation, Roth conversions, things of that nature, and especially we're focused in on observing the taxation of account contribution withdrawals. So along the idea of people having accounts, people also have income streams that they receive money from. So these include Social Security distributions, pension distributions, and also their earned income, so salary from their job. These different types of income streams combine to form their taxable income basis, which you can subtract a standard deduction from as part of the United States tax code. And using that taxable income amount, along with the capital gains that they see based off of the performance of their monetary accounts, you can create the tax liability based off of the calculations specified in the 1040 tax form. So this tax liability combined with the taxable income is if you're able to produce disposable income for the client, and this disposable income in turn satisfies a desired income that they need to, just everyday living expenses like rent, mortgage, food, things like that they need to live for a specific year. And also, the leftover money from that is considered investment income. And this is treated by the financial plan that a client possesses as contributions into their savings accounts. As a client progresses through their retirement years, they tend to receive less income source because they're not making any money, they've retired. So they tend to withdraw more from their financial accounts. So this is another area of concern that the financial plan tackles. So the financial plan basically is where we are inspecting and trying to solve some problems about how to correctly optimize in terms of end balance and tax liability reduction over clients' years.
So what the customers wanted when they started the first iteration of Terry was to analyze a way to maximize your pre-retirement savings so you can have the most money at the beginning of your retirement, and analyze and optimize to the point where you have enough to minimize the tax liability and maximize your end of retirement account balance. And this is also the third iteration of Terry, so we already have a tech stack that was picked for us, which is Java and React Frontend. And our requirements, some requirements that we infer from the project and proposal, we had to get familiar with the existing legacy code base, and we elicited the rest of the requirements from our sponsor through the missing pieces that we couldn't ourselves figure out. And we compiled them into SRS documentations. So we had a formalized, itemized list of requirements that we would have to deliver on, since tax codes are pretty complex.
So seeing as this is version 3 of the software, we inherited quite a bit of the framework already created. And so the first team in the first iteration produced primarily the tax engine and tested it to ensure that it produced the accurate tax values, or the accurate tax liability given a certain amount of income. And so that consumed the majority of the first iteration of the project. From then we went to the second iteration, where they produced a web application front end, which our client was very satisfied with, and thus we're not going to be editing or changing very much, except for adding new fields as needed to the various forms. And also they created an initial setup for the projection system to project future values of assets throughout a person's retirement. So that's where we are going to be working through, that's where we have been working through our version 3 of the software, where we're attempting to implement the remaining business rules into that and finalize it so that we can begin work on optimizing to produce the maximum amount of after-tax value on any given retiree's assets.
So we want to talk a bit about our design process. We use whiteboarding sessions primarily to brainstorm ideas with each other in our weekly team meetings. This served us pretty well because we were able to apply quick changes based off of suggestions that each other would give to the group. And once we incremented our way to a candidate solution that we thought would fulfill the requirement that we were attempting to achieve and develop functionality for, we would document that in UML and add it into our existing document phase for our project. The focus of our design work primarily fell on refactoring the legacy code base that we inherited, and we also spent quite a bit of time planning Roth conversion functionality, so that's another one of those business rules that we have to implement in order to correctly model the United States tax code. In terms of refactoring, a large effort was spent here. Quite a bit of time was spent on changing up how the database logic was structured and also the surrounding models just to represent entities within the system. There were some issues there logically that we wanted to correct before we moved forward with the project. Also, this influenced the API structure quite a bit because it has a CRUD style pass-through that's very reliant on those model objects. And also, we spent some time refactoring and redesigning the strategy system. So the strategy system contains the business logic for projecting a client's account values out into the future and generating tax liability for them. Because this is such a big part of our core mission in order to satisfy the customer's requirements, we spent quite a bit of time focused on that in order to make sure that it's properly set up for creation of the new optimizations throughout the summer. Also, we spent some time working on Roth conversions, as I mentioned. One area of concern that we have in terms of design is there are a couple areas where we want to address and have sort of guide class functionality with high levels of coupling and low cohesion that we just want to address there too.
So we began our efforts of refactoring with the database schema, where we determined that there were an awful lot of magic numbers in the code and configuration data that was not subject to very much change in the database. Now our sponsors wanted to have any of this configuration be human editable without needing to be a programmer. So the first thing we did was we pulled that out of the database and out of the magic numbers in the code into configuration files, which would then be human editable and human readable. And then secondly, we simplified the data model considering that this system operates something akin to a calculator where you set up your initial conditions, you run your calculations, and then you get your final result. We determined that any user of the system, or the consultants, which are the primary users of the system, would need to directly edit any of the fields on these data objects. So we've created a CRUD pass-through style, as Hunter mentioned, that would allow the front end to directly modify these fields through the API for use in calculations. Now some of this was already implemented, but needed some work to standardize the API.
So before I talk about the particular design details that went into Roth conversions. I just wanted to give everyone a brief overview of what this actually is, because we spent quite a bit of time working on it. So Roth conversion is part of the United States tax code that allows you to transfer money from a qualified account, so that's 401ks and traditional IRAs, into a Roth account. And this transfer of money isn't capped at any rate, like a normal contribution would be to a regular account. And the utility in this is that clients are able to actually bite the bullet and pay a bit more tax up front when they're in lower tax brackets, so that when they're later in their retirement years, they can avoid having to pay the taxation on the withdrawals when they're in higher tax brackets. This is a technique that's commonly used on a lot of financial and retirement planning strategies. So we incorporated Roth conversion calculator. We're kind of troubled to put it into the existing context of the system that we inherited, but it's important to note spending and saving strategies within the tax optimization strategy would request a Roth conversion to be performed, and then the client snapshot, which was the guide class that I kind of alluded to earlier that we're planning on tackling, would actually enable that calculation. And part of Roth conversions is that the sponsor wanted us to be able to do a forced Roth conversion from the front end, where they specify a start year and an end year with a Roth conversion amount specified. So we also are planning for that in our design with the system on the top.
So this is part of our refactor system that in redesign of the strategy system. So this is what is used in the optimization. So we have two components, two major areas that to focus on. So we have spending on the far right, far left, or far right, depending on where you are, and the bottom here and the savings. So basically, there were a lot of redundant code in the system. So what we wanted to do was use inheritance and use a strategy pattern to cut down a lot of the redundant code. And we have a strategy factory to pass to the front end the calculations of each specific strategy. And by using the different strategies, you can optimize for the most efficient, most tax efficient way to retirement plan. Yeah.
So, as the system is intended to be used for real clients for real financial planning in the retirement years, testing is of paramount importance. So we have a more or less three-tiered approach to the testing of unit testing, API integration testing, and acceptance testing. For the unit tests, when we received the system, it had approximately 0.5% of test coverage, which is pitiful. But as we've refactored the code, we've brought it up to 15% as we've added tests to the code that we've written for the refactoring. Then at the API level, we plan to use Postman to perform integration tests and go through the end-to-end system functionality to ensure that it's working as expected. And acceptance tests will have us sitting down with our sponsors to go through the results of the program, as they have their own tools that can be used to validate that this information is correct and reasonable, as opposed to accidentally running someone out of money.
So for our development methodology, we decided to run with Scrumban, which is a combination of Scrum and Kanban. We primarily focused on the Scrum side of it, but we wanted the flexibility of being able to add new work items into our current iterations. And for our development methodology, we also had sprint meetings every 2 weeks, just as a normal iteration cycle would allow. For our pull, we had peer-reviewed pull requests whenever we tried to merge back into master or the dev branches. We had weekly team meetings where we focused a lot on project level deliverables and also collaboration of design ideas and bouncing like implementation details off of each other to try to work through those types of problems with each other. And then sponsor meetings we had every 2 weeks. These were actually incredibly useful for us because of the complicated domain that you saw in the beginning of the presentation. Having the face-to-face time with our sponsors really helped us in terms of understanding just retirement planning in general. And we also were able to fill in the gaps in the requirements that we talked about and get feedback and prioritize our work going forward. In terms of artifacts that we collected, obviously we kept track of the project 4-ups, that were required by senior project. These were pretty nice because they were a conversational style of progress. It kind of kept track of what we were working on week to week, which was really nice to have and reference back to. Also, in terms of Scrum and the Kanban, we generated user stories from our requirements. We had some issues with estimation and writing to ambiguous user stories. So these manifested themselves in terms of problems with tracking our metrics for these user stories later on in the project. And we also kept a backlog for our product and our current sprint. And we maintained a defect list of our known bugs so that we could address them effectively. Now on to metrics in progress. So for our process metric, we decided to use estimation accuracy, which is the ratio of work completed in a sprint over what was expected. As I alluded to just now, we had some issues with this. We had poor tracking performance based on our inability to estimate properly. So this metric ended up not serving us quite the way that we intended in terms of evaluating the performance in terms of productivity as a team. So we're going to look into choosing a different metric going forward for that category. But for our product metric, we used code coverage, which is actually pretty nice because it allowed us to communicate with our sponsors the level of correctness and quality in the product that we were building, which is a very high priority for them. That was a big need in terms of the business side. And then briefly, expected progress versus achieved progress. When we set off in this semester, we aimed to get raw conversions done along with tax code updates to reflect the new tax legislation that was passed last fall, along with starting to develop the optimal savings and spending algorithms. So because of the large level of redesign and refactoring that we wanted to incorporate into the system to set our project up for success in the future, we ended up delaying some of these work items, but we still were able to manage to update the tax code engine, get a lot of bug fixes, and continue on those refactoring efforts that we set out to do. Also, we started on raw conversion implementation, but we had some integration issues with the end. Just integrating with the existing functionality, we had some trouble. So we were unable to meet that deliverable, but we plan to for the beginning of summer.
So some good things that came from our team. We actually had very cooperative regular meetings, and we weekly had meetings that, if there was any reason to meet again, we would just schedule on whenever schedule was allowed. And I think we brought a lot of individual strengths and a wide base, knowledge base. Some bad things that happened. We invested poorly in our early time, and we should have focused on documentation and refactoring the existing code base.
That is to say that we spent a lot of time fighting the code instead of recognizing the need to refactor right away, and that cost us a good chunk of time in the early project. So for our plan going forward, we've drafted and proposed a revised timeline to our sponsor just last week, and that has been approved. And we plan we split our time into 3 major sets of catch-up work, which is to take place from the interim into the early summer, at which point we expect to finish the refactor. So we hope we'll have a good base to work off of for our 3 major feature milestones, which are the sets of features that our sponsor would like to have by the end of the project term. And so that gives us some buffer time at the very end of the summer in case there's any schedule overruns, and also to run our final acceptance tests and clean up the code and documentation for handoff.
And that concludes our part of the presentation. Yeah? Question?
So I know you mentioned about updating the tax code stuff to conform to the newest iteration of it. Have you made any way for it to be easily updated by the project sponsor, or?
So that's the intention of extracting the configuration into the human editable format, so they can open that. And at this moment, we're using JSON. So it would be, they can look through it, they can say, oh, this is the field that changed and change the value directly, and then when they reload the system, it'll have the new values in it. As for huge structural changes to the tax code, there isn't really any way to abstract that completely.
In terms of allowing for, the client to be able to edit that. So before it was all magic numbers and it was loaded into the database just at the beginning, like whenever you first built the project. So even migrating to the JSON file is a big step up for them. So they're able to edit any of the tax code configuration values just from the regular file system now.
Do you guys think you'll actually be able to complete those three major features by the end of the project?
Yeah, we spent quite a bit of time negotiating with our project sponsor last week. So we have pretty reasonable expectations, and the way that we time box everything, it's reasonable that we'll be able to make those commitments. But we also have that about 3-4 weeks of time left at the end of summer, just dedicated to overruns and fixing specific issues that arise. Yes.
One of the tenets of refactoring is that you have the system under pretty good coverage of text, so you don't break anything. How comfortable were you refactoring 0% code coverage?
So yeah, that was a big risk that we took in terms of changing a lot of the coding styles and just changing the code to that level. So what we did to kind of compensate for the lack of unit test is we would run the system on a set of inputs and report the outputs that we got based on that. So even though it wasn't an extremely thorough test that provided a sanity check, that the major functionalities were still working properly.
And as it turned out, the system wasn't producing the values they wanted to begin with. There were a number of major bugs that were seriously skewing the results the system gave out, which would have been presumably caught with proper testing to begin with.
So it ended up, when we were going on our refactoring mission, we ended up finding a lot of defects that inspired later redesigns as well. So it's kind of like a double-edged sword.
Hi, so we are Team Bitforce presenting Project GENOS. That stands for GEINDC, Industrial Communications Networking Operating System. I am Fawaz Al-Hinaki.
I'm Kasim Ali. I'm Brian Youngman. I'm Jack Gunn.
So, throughout this presentation, we will be introducing our sponsor. We'll be talking about project proposal, as well as the development methodology we've been following, our design decisions throughout this project, and the architectural decisions and our current testing plan, as well as our current progress in the project and the lessons that we've learned and what we have in the future for this project.
So our sponsor was GE MDS. They design and manufacture industrial networking equipment. So if you think of your home networking with modems and routers, they're doing a very similar thing on a much larger scale. And it could be used in like utility companies, for example. They may have pumps or something like that that are far away from their central headquarters, and they want remote access to these devices. And GE MBS makes devices on the RF, Wi-Fi, and cellular network to accomplish this. Our sponsor contact is software architect AJ Grewell. So the initial proposal was that GE wanted us to create an open source operating system essentially for the Orbit product family. Major features would be zero-touch provisioning, which means when the device is hooked up to our network, it'll automatically receive some sort of default configuration file that the user has defined. Device monitoring and management, and possibly software-defined wide area network. So to maybe relate this to your home, a technician might come out and install a modem, install your internet. If you think about maybe a large utility company that may want 100, 200, 1,000 of these devices, it's a lot of work to have just one guy go out there and configure every device. So the aim of our system is that from one central location, they can predefine settings on every device and launch it and send these settings as soon as the device is connected to the network. The diagram that is on the left here, everything in orange would be something that we would have to implement. So the ZTP, zero-touch provisioning, FCAPS, which is just basic device monitoring and configuration, SD-WAN, that's going to be a software-defined wide area network. So so these devices, they're going to be wireless. So they have to somehow know who each device is and how to talk to each device. The blue and the gray, those are something that's going to be provided by some other service that we'll go into a little bit later. And we had to come up with a device-specific abstraction. So GE is not the only one that makes these devices. There are going to be other companies that make them. So any existing tools, any existing networking tools, they do not already have the ability by default to interact with GE devices.
So project requirements and goals. Most of our requirements were obtained from the document provided to us by the sponsor and our meetings. In about the first 4 weeks, we met 4 times. By then, we had a pretty good idea of what we need to do, and we also recorded most of the requirements. So we decided that the application is Gynos, but it has 3 major components, and the component that we decided to implement in this semester was zero-touch provisioning, which was basically, on a high level, we were assigned with generating configuration files for devices automatically based on a list of user parameters and templates, and then sending the configuration files to the devices once they connected to our system. There were existing technologies that we could have used. There's Open Daylight, Network Controller, and SALT. There's also Ansible. We could have used these, but we decided not to because they provided way more functionality than we actually needed. So we would have only used these for communication with the device, which we could have done. The sponsor actually has a small library that we could have used to communicate with the device. So we decided not to go with these because we didn't need all the functionality provided by them.
Okay, so for our development methodology. We originally went with Scrum because between the 4 of us, that's what we've had most exposure with co-op and at RIT here in classes. But this is what we didn't see happening. Scrum requires the team to be extremely experienced. To be honest, we were not. We had no idea what the domain was, and we have never worked with this tool or the tool and framework that we decided to go working with. So this is what ended up happening. We slowly kind of drifted into a more Kanban approach. Now, Kanban provides several things that Scrum does not. It provides continuous delivery. What I mean is, we don't have to wait until the sprint is over in order to deliver a product. We also we can introduce changes and be able to change whatever we want mid-sprint, or what Kanban calls it, cycle. The cycle is the lifetime of an issue. It goes starting from new issue, backlog, in progress, review, and to done. I believe you can't see that here, but that's how. Kanban embraces three main principles. That's visualize your workflow and limit the amount of work in progress, as well as enhance the flow as you see fit. In order to work with our methodology, we've started working with the tool ZenHub. ZenHub provides a board of the visualization of items. It allows you to assign work to different developers, as well as estimate the time it would take you to finish the issue, as well as be able to move things around whenever you need to.
So we made a few decisions early on in the project, or I guess the main decision that we made, because Seema already talked about a little bit, in not using Open Daylight or another similar service. Instead, we decided to go with a RESTful microservice framework with a client-side rendering for the front end. So some of the reasons that we decided, or the original reason we were looking at Open Daylight, is because it actually has a little bit of UI development functionality already built into it. But the more we started to look into it, we started to find a lot of issues with it, such as incomplete, incorrect documentation. We were having a lot of trouble keeping a consistent development environment going. And the more we looked at the actual requirements of the project, the more we realized that we were really only going to be using the netconf portion of Open Daylight, which is essentially the protocol for talking to the devices. So once we realized that our sponsor had actually already implemented a small Python package that would handle all of the netconf communication for us. So we decided to go with that instead.
So there were two major components to the application. There was a RESTful API application. We used Flask Python framework to develop that component. Flask also has an extension for RESTful API, so that made it quite easy. We picked Flask because Python has a lot of documentation. It's a very popular language. It also has a bunch of libraries that we could use. And also the library that was provided to us for communicating with the device was in Python, so that made integration quite easy. So developing the Flask RESTful API enabled us to separate the front end from our back end. So whatever we could do from the front end, we could also do through the command line, which was one of the requirements to be able to use curl to pretty much do anything that we can through the front end. Python also enabled us to structure our directory structure in such a way that we can easily sort of modularize the application, so we could have modules that we can update or remove or delete or add, so that made it easy to modify the modules. That's it.
So as Kasim said in the last slide, one of the requirements for this project was that it has a web UI, but the web UI is not absolutely required for the user to use. They could use this potentially just command line interface. So we completely separated the front end and the back end, not only for functional purposes, but it also helped out for development purposes. One person can be working on one side of the application, another could be working on the other side, and they don't conflict. So one problem on one side does not affect the other. We chose to develop the front end with React. It has a great capability for completely client-side rendering. Very responsive. It offers a lot of developer tools in any modern web browser, and there's a lot of community support. So it really made developing the UI easy.
So just visualizing what my teammates have been talking about, this is a high level of our architecture. As you can see, the user is able to communicate with either the REST API or the front end directly. The REST API would return a JSON to the user, whether they're not if they communicate through the API directly, they would return a JSON of the response. If the user's using the client-side front end, the API would send the JSON response back to the front end. The front end would use a React component to render the response and visualize the front end for the user. The REST API communicates to our back end, which has our business logic and MySQL server, and as well as the two-factor authentication, which is still to be implemented. We currently have one-factor authentication. The entire backend communicates with the device or devices, creating whatever request that needs to be done, such as initial device configuration, etc.
This is just a representation of the UI architecture. It was built as a single-page application, React, as I had mentioned. Each package that you see down below will contain a React file for the client-side rendering, a CSS file for styling, and then an API file that will connect to the backend. A major part of keeping the API separate from the rest is in the future, in the event we want to add more support for, say, OpenDaylight, as was mentioned previously, or some other module that uses REST API, it would be very simple to add back in.
So the backend architecture is pretty much defined by the API. For the most part, throughout the system, there's almost a one-to-one API endpoint to a model somewhere in the database. So think if you have parameters or templates or anything that's stored in the database, there's typically a pretty standard post, put, delete API associated with it. The only exceptions for that are things that create relations between the things stored in the database. So, for example, assigning a template to a device group. That's just essentially creating relationships between the uploaded templates and device groups that have been stored.
So for testing, we've decided to go with the Python unit testing framework. That's because we're already using the Flask framework for our web needs. The Python unit testing framework kind of integrated very well into our project. We're using what we're mainly testing is our REST API requests, and we're using our database connectors that Doug talked about in order to fill in the prerequisites and to verify that the REST API requests did what they're supposed to do. Now, every time one of us commits anything into the project, mainly to the master branch, the tests are ran and it reports back the failing tests. Now, in the future, we do plan, if time permits, to implement UI testing via Selenium.
So currently, we have most of the ZTP application done. User management, we can have users with different roles. We can have templates. We can generate templates automatically, and we can send templates to the devices. So before ZTP, if we had a bunch of devices and we wanted to update the functionality or change the functionality of those devices, we would have to plug into that device or have to be on the same network that the device is, generate a config file manually, and send that to the device. ZTP basically automates the generation of the configuration file and also automates sending the configuration file once the device is ready. So most of these functionality, this is the core functionality that we agreed upon, and this is completed. The lessons learned, we gained quite a bit of domain knowledge. We didn't know much about the devices, which is the PyOrbit devices, which is our Orbit devices by General Electric. We didn't know what they did, how they worked, or how to communicate with them. Now we have a pretty good understanding, which should make development faster in summer. Another lesson is that we should have done a bit more research for the technologies we chose. Throughout the project, we kind of had second thoughts about some of the tools that we chose. So in the future, we'll probably take that into account. Also, process, have a well-defined process and follow it thoroughly. We did have Scrum, and then we kind of switched to Kanban, but because we switched from one process to another and we didn't really fully follow Scrum, we didn't have many metrics to reflect upon. So that's one of the lessons learned. Also, role specialization. Each member of our team is really good at developing a particular component of the application. This made the team overall more efficient, and we plan on keeping it that way for the summer.
So over the summer, in the future of the project, one of the first things that we're going to be working on is just kind of a little bit of refinement of the zero-touch provisioning. So we need to go back, and there's some error handling that needs to be worked on, add some standardized HTTP return codes for specific failures and things like that. And then once that's finished, we would like to look at, or we are going to look at authenticating devices using a Windows SCEP server. And so basically what that'll do is whenever a device attempts to connect to the network, first it's going to have to go through the SCEP server and get an actual certificate so that we know by the time it contacts us, we know that it's a safe legal device to communicate with and that we don't need to worry about any sort of malicious activity from it.
So in summary, we discussed the ZTP application, which was the original goal. Have the core functionality of the ZTP application. We were able to complete that for GE. We also discussed our development methodology. Initially, we started out with Scrum, and then we kind of switched over to Kanban. We also discussed major design decisions, mainly not using existing systems. Architecture, front end, back end, React for front end, for back end it was Flask mostly. Testing with Jenkins and also using Python testing frameworks. The current progress, completion of the ZTP application, and future what we're gonna do in summer. Also for risk management, we didn't have a formal way of addressing risks, but we met at least once a week and we discussed different risks that could potentially be blockers, and we recorded those risks. And when we met the sponsor each week, we talked about those risks and we did what we could to mitigate those risks. That's all. Questions?
What does two-factor authentication look like in network operating?
Okay, so it would look, so the way that our sponsor wants it is you have your first authentication, that's your password. The two-factor authentication part is what we're not even talking about in terms of the device itself, we're talking about in terms of the users that are using this application. So we are either doing the email two-factor authentication or phone SMS two-factor authentication.
How would you know your test time?
Okay, so his question was, how would you know if your tests fail through Jenkins? So we've set up two forms of, we're technically still in beta mode for testing, but we've set up two notification systems. One goes directly to our emails, for developers, and we integrated it with our Google Hangout, which is our main method of communication.
Are these relatively lightweight computing in terms of computing power, and how do they handle React as a framework?
Are you referring to the test?
To the devices themselves.
So the devices, they're not going to run. They're going to connect to our program. So the idea here is that you have a bunch of devices and you have some configuration you want to set that to. Maybe you have a device on the other side, your own device, and you want to, let's say, you want to get data from it. So when you first obtain one of GE's devices, it doesn't know anything about your device. So you're going to have to tell it, hey, there's a device behind you, get data from it. So all our system does is you go in, you set it up, and you say, I have this device based on the serial number, and I want to define a configuration file. GE will provide them some sort of base configuration file, template that the user can upload, and they will define a parameter. So they might say, go to the device behind you, let's say an IP address. There might be an IP address for the device connected to your GE device. They will plug that into our system. When the GE device connects to our system to Geno, it will alert it, says, hey, I'm connected. All Genius is going to do is open up communications with the device and send the file. So it doesn't actually need to run any of our software.
Any other questions? All right, let's thank the team.
Cool. Good afternoon, everyone. We're the Wegmans team. I'm Adrian.
I'm Michael.
I'm Tom.
I'm Chris. So today's agenda is going over what the project is, project overview. We're going to go over our technology and why we chose to use that technology. Same with methodology, what we chose, why we chose it. We're going to go over what we've done for testing and our plans to go moving forward, what metrics we've been collecting, our current progress in our current iteration, and then we'll take questions and comments. As a quick side note, we signed the most restrictive NDA, so we're not allowed to talk about a ton about the actual application, so we're going to go more in depth about methodology and stuff along those lines. So, our project was to develop a mobile application to assist Wegmans in meeting food safety goals. This can include things like taking temperatures and cooking monitoring. The application needs to perform 3 basic tasks. It needs to allow employees to actively monitor products and keep track of when they need to be audited. When a product fails the safety requirements, an employee must be able to perform a corrective action on the product to bring it back in line with those standards. And the application must be able to synchronize that data from the device to the other devices in the store. By performing these tasks, we hope to achieve 3 goals. Those goals are improving the current record-keeping standards of Wegmans,
reduce the time spent by employees on the auditing and food measuring process, and to emphasize usability with universal symbols. Many employees might not be speaking English as a primary language, so it's important that we take that into account when developing our UI.
All right, so I'm going to quickly talk about some of the technologies we used in our application. So one thing we discovered when we came into this project is that we didn't actually have a lot of freedom with choosing the technology. Wegmans came to us with some defined technologies that they wanted us to use. You can see those here. There's the Android, which is all the devices we're deploying to our Android OS. We got Xamarin, which is a cross-platform framework, which allows us to develop in Android, iOS, and the UWP, which is the Universal Windows Platform. And we're using .NET Framework and C#, which just follows standard Microsoft standards. The reason we were told to use these is because we had to comply with Wegmans' internal structure. So one thing we actually did get to choose was the local database on the devices that we're going to have our application on. We actually looked at a number of different technologies, including SQLite 3, which is actually included in .NET. The reason we actually decided not to use it is we found that SQL databases were not very reliable on mobile applications. And so we decided on Realm, which is a document-based database. We chose it because it's cross-platform. It was built with Xamarin in mind, so it integrated nicely into our required technology stack. It's free and it's very well documented. It has something called the Realm browser, which actually lets you view your database structure. And it's very mobile friendly. It also allows, it's also got a offline first emphasis. So since our device needs to run both offline and online, it actually is really good for that.
Moving on, as a team we had to determine what is the methodology that we want to use for this project. Before we go in discussing what was exactly what we picked, let's go through the rationale of what we needed from our methodology. First and foremost, when the Wegmans team came to us, they told us they're an agile team and we wanted to comply with what they were doing already. So we were looking for an agile methodology. As a team, we also wanted to see something that would allow us to accommodate for evolving requirements as the project goes. Initially, from what we understood, we knew that most things were set, but we knew that still some things were changing, so we definitely wanted something agile. Second of all, we wanted something that had short iterations. As a team, we wanted something that had short iterations that helped us keep pace. We don't want something that lasts a whole semester, and then when we push everything to the last couple days, we're trying to blitz through everything. So we want something with short iterations. We also wanted something that would allow us to be adaptable to changes. So this short iterations help us achieve that goal. Thirdly, we wanted to, as a team, we wanted to elicit our requirements as user stories. So we wanted something that allows us to do that. Finally, we wanted something that would give us a living product. Something that we can see changing as we develop, something that we can show to the Wegmans team that we're making progress. And as a team, that we know that we're doing something, we're going the right way or the wrong way. We need some feedback from that. From all these four ideas, we came up on deciding that we wanted to use feature-driven development with some modifications along the way that came up as we were talking as a team and with the Wegmans team. So what is feature-driven development? It has short 2 to 3 week iterations. As a team, we decided we're going to have 2 week iterations. It helps better with the timeline that we have for the project. It has continuous inspection. We have a model that we try to stick to. It's a ever-changing model that we refine every time, and that's our guide through the project. That's essentially what we follow when we try to develop stuff. It has regular builds. At the end of each 2 build iteration, we have a build that we can present that is stable, that can be used at any time. It has all the features that we said that we're going to implement or that we could implement. It gives us good visibility. As I mentioned, this build is there. The Wegmans team can access it at any time. We can access it as a master build that is ready to see. And any changes that want to go there have to be tested and then go in there, and then you can see it at any time from any side of from either the Wegmans in our team. Finally, we want something, it ensures the delivery of a minimum viable product. This is again going back to the living product. At the end of each iteration, we have a thing that has the requirements that we decided to tackle. So the major modifications that we did to this methodology. We really wanted to keep it as track as user stories, and the Wegmans team also said that they prefer user stories. So instead of keeping features, or keeping track of features, We initially built this list of features, and from that we created the user stories that we're going to be implementing as we go through the project. So how does the methodology play out? The first thing that we did as a team after the first couple meetings was doing a domain walkthrough. We needed to understand what we were doing. First, as a team, we tried to understand what the whole project entitled, and then as a team, we made a couple visits to the actual Wegmans stores to understand exactly what they needed firsthand and what they were doing. From that, we developed an overall model. This is essentially a first draft of how we think the whole system is going to look. From there, we go into the second step. We developed with the Wegmans team through a couple weeks. We elicited requirements. We created user stories together that we think we're going to fit this project. From those user stories, again, we keep refining the initial model that we have. That's our main guide through the project. From then on, it's the iteration parts, and this is where we currently stand. Each iteration starts with the planning. As both teams, we get together, we decide which are the user stories that we want to implement for this iteration. We decide on them, we agree on them, and we divide as a group the work that we're going to do. Next up, it's the design phase. After we've divided the work, we decide, each class is going to look like this. This is the method we're going to implement, and we go from there. And again, we refine the model as needed. Finally, the biggest time of the iteration is during the building phase, where we code, we test, we integrate, and we push it into our master build.
So this is a quick list of the technologies we utilize to assist us with our methodology. First up, we use Trello. Trello allowed us to use almost a sort of Kanban board to keep track of our internal documentation and various other things that didn't apply directly to coding. We also use it as a brief risk management tool. We use Slack to talk because we needed a communication tool. Mock Plus is a big important one. Mock Plus is what we use to develop wireframes. They're interactive wireframes. So every week or every couple weeks, we develop an interactive wireframe of what we think the product should look like. We then either present it to Wegmans in meetings, or we send it to them outside of the meeting so they can review it internally. And this gives us a really quick turnaround on fixing problems with the user experience that we won't have to go back on later. So we can sort of continuously build up to these big wireframes. And then finally, we use TFS for everything else. TFS is the Microsoft Team Foundation Services, which Wegmans has provided to us. It contains our Git repository and all of our branches. It contains all of our user stories, and we can assign user stories to individual people in TFS. And then we have a way of tracking who's doing what. We have a paper trail of who's doing what in the commits. It also allows Wegmans to go in and manually take our master or staging branch, do code reviews on the pull requests, and pull down and compile and run on the emulators or on the devices themselves. As far as testing goes, in the future we plan to develop unit tests. As it stands right now, everything we've developed has either been bare bones front end or a framework for things in the future to come. So there's not much functionality behind which we can unit test yet. But we do have a couple of technical metrics that we use to keep track of things. We do internal code reviews. So every time there's a pull request to our staging branch, we go in and we approve it individually to make sure that it complies with what we consider to be a good coding standard. And then Wegmans approves everything going into the master branch. So everything from staging gets approved by Wegmans so that they make sure that we're not doing something that we shouldn't be doing. And finally, we're currently doing a lot of end user testing to make sure that the viable product is viable at the end of each iteration, and that we have used the wireframes that I talked about earlier to have an interactive walkthrough that people can actually use.
In order to measure our progress, we have decided to collect three major metrics. First is the process, and this would help us to identify our velocity and what we need to tell Wegmans what we're gonna do next, or how much user stories we're gonna do next. Second, the technical metrics. As Chris mentioned, that we do not really have things that are tangible to be testable. So the testing coverage will be used in the future, in this and the future iterations. And finally, the personal metrics. This we have been collecting since week 1. We have been collecting the the time and tasks we have been doing and times we have been spending on these tasks. And also later on we started to collect the number of user stories assigned versus completed per team member. This velocity graph is generated by TFS, and it shows our 3 iterations, and the last one is our current iteration that will end in 2 days. For the first iteration, we were able to complete 9 story points, and this is due to the fact that we started this iteration a week before the spring break, and we also wanted to start some with the needed stuff so we can adapt to the process and to the technology as well. In the second iteration, we were able to complete the 25 story points, and in here, as you can see, we are gradually increasing because we wanted we thought we can do more than what we did, and in the current iteration, we are doing currently now 37 story points, and hopefully this will end this Wednesday. This graph shows that the green color shows the cumulative flow. The green color means the closed stories. The dark blue represent the resolved stories, and the light blue represent the active stories. In each peak, in each green peak is an end of a sprint. The dark blue is stories marked as resolved and should finish off the green peaks. This graph is meant to show how stories are created. This graph is meant to show how stories are closed versus how they are open and active. Unfortunately, we didn't actually do it probably at first because we were getting used to the system and the software, and often forgot to actually close or resolve user stories. So the dark and light blue aren't totally accurate at this moment. For our current progress, as for so far we are wrapping up for sprint 3. That means the third MVP will be sent very soon to Wigmans for their review, and we are also waiting for their approval for the mock-ups for the next iteration. We are always trying to be one iteration ahead when it comes to mock-ups to reduce the amount of changes and the amount of edits. For reflection, there are 5 major points we would like to reflect on. The first point is the hardware insincerity. So we are at this point we are not really sure what devices and what tools that we will be using and what devices we will be deploying to. As powerful as Visual Studio can get, it is not really fun to use. It crashes that often. It's not really cross-platform friendly, where we are having issues with compiling code using Mac and Windows, and also it is also not 32-bit. For database, as we have discussed, we would like it was hard to find a database that would be fully functional, work in a limited resource environment. We aren't the only application that will be running on that device, so we'll need to have less footprint as possible. Also, Wigman supplied us with codes that we need to integrate with our own code, and so far we aren't really able to compile that code. Finally, for our sprint cycle, we changed our sprint cycle to better match Wigman cycles. We also had an issue where sprints would end on Friday, and when sprints end on Fridays, we didn't really have, we didn't find people or people weren't around to finalize things. And for that, the next sprint before Monday, having the sprint ends before Monday was proven to be difficult. thank you, and we're here for questions.
Yeah, what's up?
So in your process, you said you divide your work and then you work on design. Do you do that individually or do you have a plan to keep things consistent?
Yes, so what I meant with that is we assign which each one is going to be working on, but as a team we go through the design. And then once we have that design finalized, everyone goes on their way and works.
So I saw that in terms of your square velocity ranked up in terms of what you take on. Do you think that's because underestimating the amount of story points is the work items would take up in the beginning, or do you think that you increase the productivity?
So like we said, the first iteration was over spring break by accident, sort of. So we had a week where we were working, but we weren't totally focused because we weren't actually, a lot of us weren't here. We were also learning the technology. None of us were familiar with C#, .NET, or even Visual Studio mostly. So we were or TFS. So we were actually learning a lot about the technology we were using. But it ended up working out okay. So that's why we ramped up really far from 9 to 25 in the second iteration. And now we're still finding our legs in the technology, which is why we're still ramping up. I think this iteration is the first iteration that's truly near optimum performance. So we're going to hopefully stay around 30 to 40 story points moving forward.
So I know your project specifically has a large number of stakeholders. How have you been managing requirements, priorities, and that sort of thing with a lot of stakeholders?
It's actually very interesting. It's our meetings. It's the four of us, and from the Wegmans team is usually 6, 7, 8 people. It's a lot of pull and push. We have to be honest as a group. This is what we can deliver. This is what is realistic. But we also need to be understanding of what the Wegmans team wants, and not just corporate, but also the people that are on the floor. So it's a lot of discussion, and it's a lot of good discussion that not only do we get the requirements, but we get better understanding from the domain itself. So the way, again, that we've handled it, we're meeting every Wednesday. That's how it goes. We meet for 2 to 3 hours usually, and it's a lot of talk. It's a lot of putting things on the table, understanding what they need, from our perspective, putting it into ways that we can implement it, and then discussing what's viable, what's not, and then as a group, both teams decide, okay, this is what goes, this is what doesn't go. And again, as we've mentioned before, having the mock-ups really helps, because as much as this app is about what's behind it, there's a lot that is about the interactability and the usability of the actual app. So that helps us a lot decide what comes in and what's not a back-end requirement.
So you mentioned that you guys have a lot of requirements generated from those long meetings. How are you guys documenting all of those and keeping track of them over the lifetime of the project?
Every user story we create is logged into TFS under our backlog. So we have, I think, 40 user stories in there currently. And sometimes they're really high-level user stories that sort of encompass maybe a lot of functionality that we then, when we get closer to implementation, we discuss with the Wegmans team what this might entail, and we break it up as we go. So we have 40 user stories currently, half of which are probably sort of small, manageable, and more large for the future user stories. And in terms of logging what gets changed when, TFS handles most of it, but we aren't particularly concerned with that.
Any other questions?
All right, thank you.
Thank you very much.
Glad to see such lively faces at 6 o'clock. We are Team Orion, and we worked on the StarRes check-in system, sponsored by StarRes. I'm Thomas Faticone.
I'm Scott Barron.
Dylan Ho.
Quentin Guert.
So the first thing we wanted to start off with, who is StarRes? So StarRes, the way that they describe themselves is StarRes has been developing, delivering, and supporting housing software solutions to higher education. So they mainly deal with housing and conferencing, and specifically under housing they deal with things such as roommate placement, bed management, select roommate selections, all stuff of that sort. And they actually service universities in over 100 countries, and on top of that they service 3 million students, and so they brought us in to do this.
StarRes gave us the main project requirement of developing a prototype for a new concept for students to check into universities around their campuses with. While the requirement is ambiguous by itself, during the requirement collection phase, we also noticed the differences between the colleges and their processes, and then on top of that we needed to account for the accessibility needs of the various students on the various campuses.
So our main focus was on a typical check-in day at the start of a school year. So we found that for a lot of universities it operates something like this. The student and or his family arrives, they will collect the key to their apartment or dorm, shuffle around, unload everything, drag it up to their room, and then, especially for freshmen, will then go on to first day activities, such as any kind of paperwork, general social activities, and such like that. We found a couple of different things with universities here that they would like to kind of speed this up. So can you move on to the next one? So we found that there's a lot of problems involved in this day that slowed us down. Weather emergencies and just general communication updates a few universities reported having. So suddenly inclement weather that forced everyone to go inside, or even something minor such as last minute housing changes for the student that he should be aware of. On top of that, we've had some universities complained of having traffic flow problems. We had one university that straight up admitted that they had a hours-long gridlock because their university's freshman move-in day coincided with a sporting event, and everything in the area basically stopped. And as well, we had the lending and borrowing of carts and other unloading items, as well as requesting assistance was something that some universities wanted at. So they wanted to correct all this to hopefully speed up check-in, make it more automated, and just get through it without as much hassle as it sometimes is. So StarRes in general wanted something that would allow them to give a leg up on their competitors and market them to universities. Discovering these problems, we decided to create a system that would allow StarRes to handle all those little problems. So a messaging and update system that both administration and just general volunteer workers could use to be updated of any problems, security emergencies, weather, or send updates out to students and their families of any last minute changes, such as last minute housing assignments or changes in directions. Maps and directions to direct you to what parking lot you have to go to, where do you pick up your key, where is your apartment, and stuff like that. And then a system for requesting assistance for various helpers who are moving about, helping people move in, as well as borrowing and lending carts and other items that some universities like to kind of keep track of where that's all going.
So this is our tech stack highlight. Just to highlight a few of them off the list here, we got Vue.js in a Node.js framework using the V8 LTS edition, packaged with the NPM package manager, and then Postgres for our database with Apache Cordova as our build tool. So why did we use Cordova? Because it allows for Android, Apple, iOS, and Windows Phone applications to be maintained under a single code base. It takes a static web app and is able to build it into near native app performance in their respective platforms. We used Vue.js for the reason of the componentizing the front end and code reuse. We have a map component that's used on at least 3 of our other pages, so we were able to rip that functionality out, put it into a component, and reuse a single component on 3 pages, saving the time of having to re-implement. Vueify is the front-end component library that we use. It follows the Google Material Design standards and also uses global theming for its coloring scheme, or its layouts and primary, secondary colors. We use TypeScript for the reason of debugging and just the helpfulness of type declarations. The Postgres database is used by StarRes as well, so that was the tool that we decided to just keep the same, keep consistent, and so we use the Postgres SQL to maintain our user data instead of like NoSQL, which is more common in Node projects. That's because our data is highly structured, which means that the relational database would query much faster.
So our process background. So we don't use strict Scrum, so we say we use modified Scrum. And the main difference is that we don't have daily stand-up meetings. It's kind of lucky that we have at least 2 days where we can meet up. So dedicating ourselves to at least 5 days, that's quite difficult. And we have 2 to 3 week sprints, and that's mainly because there is some variability due to the sprint scheduling, and it just doesn't always work out. We do demos every week. We do every 2 weeks, but we like to do it every week just because we like that constant feedback mechanism that these demos give us. And on top of that, we track our user stories in UTrack, and this also has our backlog and our sprints and stuff. And we do weekly 4-up charts, and on top of that, we have our metrics, our story points, and categorized hours. So the phase 1 that we went into, which was requirement solicitation, just as a reminder, we didn't really get that many requirements. There wasn't a vision of what this project is to be. So we had to spend a majority of our time doing requirement solicitation. It actually took 9 weeks to do it. And on top of that, the requirements came from our personal accounts of what check-in day was, but it's been 6 years for most of us, so we kind of forget a few things. So we elicited the help from some of the StarRes customers. These were universities, a various amount of public and private universities, 2 of which were in the United States, 1 of which was an international, just so we can get that differing type of check-in process. And the whole goal was to kind of validate or give us some indication about what we need to do further research into, which is great because that's exactly what we got from it. And the goal of this was to seamlessly incorporate, so this really helped us get all the ifs and buts that we were forgetting about to begin with. And so the deliverables from this were the interview notes and the envisioned check-in cycle, which is what I'm about to go over. So the envisioned, so the domain model, if you can take a look at this, the main points of it are dorm rooms and students. Obviously, this is the whole check-in system. Students are checking into the dorm rooms. So the secondary components of this are things that we don't necessarily interact with per se, but they are still important in our process, would be things like beds and keys, and anything else is tertiary. So the envisioned check-in flow, it started out coming from our own personal experiences in our interviews, and it came to be 4 main components. We have arrival, key pickup, unpacking, and park walk. And as shown here, this is the first step, which is arrival. So they detect the arrival. Students get the notification to maybe download the app, or if they already have it, they get the notification, hey, start your check-in process, you've come to campus, you're ready to go. And any information that needs to go exchange between the 2 would occur in the 3rd step. So the key pickup, student will get the notification to go to a specific location, and then they arrive to the location. Depending on how the university wants to check them in, then they'll go through one of these little branches. So one of the key points is that we wanted to introduce maybe new technologies or to seamlessly incorporate. So we tried to take as many branches or differing ways to check in as possible. So one of the things that we saw was auto check-in through beacons. Another one was geofencing or NFC check-in. They actually do use NFC check-in, but it's a student will go, or they do use some sort of manual process. So that is one thing that they wanted to look into. And as such, there was a possibility of not having a physical key, or there was a possibility of having a key. So this just demonstrates what happens if they actually do have a key. So we would have a key holder actually come to you or come to the student and just hand off the key. So the third step, which is unpacking, the student gets the notification, go somewhere, start unpacking their belongings, and the helper would get assigned to them and they would get the notification, please go to this spot, start helping this family out. And as such, the student will also get a notification maybe about the information, about the helpers, just so that they know who's actually going to help them. And the student will unpack with the helper marks them as done once they're finished, and the student will get the notification as to the belongings. And then we work into the last step, which is park walk. The student will get the notification to move to a retention lot. This is just to make sure that the cars are out of the way, that they're not clogging up any important points in the university. Then they will get a map. They'll be advised to go back to their dorms. They'll get a map. They'll get some notification that says, please go back to your dorms. Then you're going to start bringing all your stuff into your dorm room. And at that point, if you don't utilize the QR check-in system, which is another method that we decided to implement, or which we decided to investigate at least at this point, they would take an inventory listing just for purposes of insurance maybe. So then we worked into our second phase, which is prototyping. So prototyping took that Envision check-in system and it outputted a low-fidelity paper prototype, something that we just kind of did quickly just so that we can run through a few of them, and a high-fidelity prototype, which is on Proto.io. So this took 3 weeks' worth of work, including spring break, and the demo, each week we had a demo just so that we can get that feedback from our customer. So I'm going to show you a little demo of our products. We have, which way is it? This one. So this is, where was it? Full screen. So I would show you guys in the preview mode, there is a nicer display, but because there are some aspects about mapping and trying to get their location to move on to the next one, we had it set up such that it was timed, which is kind of annoying. So for this presentation, we'll just walk through this. So this is our home page. This is what the student will land on as soon as they open the application and log in. Here are some of the pages that we see branch off of it. So one of them is an events-based calendar page. We didn't want a typical calendar page because we wanted to feel, because students usually they'll say, oh, I have to go here, I have to go here. We wanted them to be more excited about their events, so we implemented it in this fashion. We also have a campus map page, which is just your typical display. It's going to show where on campus you are, different buildings, and that we're utilizing Google Maps, and that we have done right now, so it's really nice actually. And where to park, similar to campus map, except you have this little bottom bar where you can select a specific parking lot, and then it'll put a target on it so that you know specifically where you're supposed to go. So this is the start. This is the gallery page. This is the start of the check-in process. This first gallery page is just specifically supposed to get information to the student about the university that the university wants to tell the students. So this is things like notices, such as safety notices like keep your eyes on the road, don't pay attention to the app, anything that the university might want to tell the student. And then the last page of this, which looks like this, is where you actually begin your check-in process. Both of these buttons won't persist on the page. It'll be either one or the other depending on when you look at the page. And then as soon as you start the process, you'll be told to go to the parking lot as before. Here's a queue page. So you'll get how long you're supposed to be, your current position, and where you're going to be picking up your key at the bottom. Then as soon as you're ready for the queue, you'll go to that location. It'll give you an indication, hey, you're ready to come pick up your key. Please come to this location. Then you'll get your unpacking one as soon as you get your key. So you'll go into this unpacking queue just to make sure that you're not clogging up the line in front of the dorm building, making sure that there's efficiency throughout the entire campus. And as soon as you hit 0 on your current position, you'll be given this, which is it's time to unpack. please go to this location, this parking spot, and then afterwards you will be sent to the unpacking page. So this is where students will be given the indication, please unpack your stuff. If you want a helper, please request one. If you want a cart, please request one here. And we give the option for the student to actually determine when they're finished unpacking. So if we wanted to request a helper, we get a profile so that they know who's actually helping out. And there's another parking one. Then they're asked to find their way back as soon as they're at the retention lot. And a simple dorm checklist. And then we are back to our presentation. This one? So then our backlog creation, we track everything on UTrack. This is a sample user story that we have, points estimated, and a little bit of a description. And all estimations are done on Planning Poker. Yeah, that's fine. And then phase 4, which is our current one, is coding, so that we have 3 weeks of, we've been in coding for 3 weeks, and it follows 2 to 3 week sprints, as I said before. At the end of each sprint, a demo occurs. Of course, we haven't really gotten to this point because we are currently in our first coding sprint. And the current model goes through cycles, so this is just to make sure that we have a working product by the end. So we work on core functionality first, and then secondary and tertiary features as we go further on. And just to mention our get flow process, we have 2 branches, staging and master. This is just to ensure that our master branch is always working, that they can always ensure that we have a working product. And so here are a sample of our metrics. We have story points, and then we have effort categorized. This is just to give a good indication about where we are, how much effort we're putting into things.
All right, so problems encountered. Most of these problems were previously mentioned. When we started off, we had very little to go off of as far as formal requirements. It was more of a vision. So we had to go through and get all our requirements together. We had trouble communicating with some of the universities that our sponsors gave us to communicate with, and these 2 issues led to the impact of having a slow start time and the long 9-week requirement solicitation period. What we learned is that we needed better avenues of communication. So, some future risks, limited time. Some of us are moving into full-time jobs as we're finishing up the senior project of the summer. The university contact issues, and we had to deal with feature creep since the requirements were not originally formally defined. Impacts of this could be time not being spent optimally, having to scale down the application, or not being able to get everything done. Some mitigation steps is to lower the scope of the application, to come up with contact points for the customers or for the universities, and to have a constant reevaluation of our scope and its feasibility. So, future plans, most of these pages were shown. Our must-haves, we've got the main pages of the applications listed there. We have the would-be nices to have, which would be like the schedule page, the checklist page, the campus map page, and the where to park page. 3 of those of which branch off the main page but are kind of extras. Then we have stretches, which is implementing geofencing, beacons, and a QR check-in. And then other future plans are to contact those universities again and have them look at the prototypes that we have built and give us feedback. Any questions?
Yeah. So you mentioned 2 to 3 week sprints, but do you know if they're going to be 2 or 3 weeks, or do you plan to go from one to the other?
So they're mostly going to be 2-week sprints, but as I said before, there is a variability just because of those. Sometimes breaks kind of break them up a little bit, so in those cases it'll be 3, but most of the time they're going to be 2-week sprints.
So what level of, do you know what level of implementation StarRight is looking for from you?
So they have a little bit of, there is a lot of bit of concern around that. They're mostly looking for a working product. They really like our prototype, so they would like to see all of our features working. But we kind of assured them that we will try to at least get the core functionality down, and if any secondary components can come along with that, then that'd be great, and they were happy with that.
So you know if they have any plans with testing of these for rolling it out, or is that far in the future?
Yeah, that's far in the future. What we were given was come up with a concept and prototype it. We should be following software tests just like any other software project, but in terms of polished, complete work, we're not expected exactly to turn in a finished product.
So you guys mentioned that you're using Scrum, but it seems more like you guys are following a waterfall sort of methodology here. What are your concerns about that?
So I kind of thought that it does sound a little bit waterfall, but the thing is that we don't know any of our requirements up front. So that was what was preventing us from doing something like that. And the main reason why we wanted to utilize Scrum is because we wanted to have those demos, we wanted to have the formalization that the customer is in power, at least at this time. That they can manage us, that they can throw in a requirement. If they have an idea, then they can insert that in. We really wanted to elicit kind of the help from the customer because we are very limited in how we view the product in of itself. We do have check-in day experiences that are very valuable in this such of a product, but the customer really does have the insight about or the sponsor does have the insight about what their customers need. And that's what we wanted to enforce through that.
Since you're not going to have a complete production-worthy product at the end, what are your plans for transitioning your work to StarRez?
Do you have that? Oh, okay. We're going to. Well, they actually haven't told us what the handoff is, whether or not we're handing it off to one of their full-time teams, or if this is going to be handed off to another team of some sort. So who we're handing this off to hasn't been exactly described to us, but the steps we're taking in terms of documentation, source control, and versioning control should make the transition and the handoff much easier. And I know going into this term, one of our big things is going to be locking down how they want the transition so that we can do the transition. Did that?
Yes.
Okay.
Let's thank the team.